Hello friends, this question is from the test series 4 from the chapters of networks, and it's a 2 marks problem. In the problem we have a one resistive network which consists of three energy sources. One 6-volt battery, and there is a one 5 ampere current source along with a one 10-volt battery source. And we need to find out the voltage across the terminal A and B. That we need to find out. So a circuit with the multiple energy sources, we have a standard theorem named superposition theorem, which needs to be applied as kind of questions. Superposition theorem. So what the superposition theorem says that according to superposition theorem, if any linear bilateral network we have a more than one energy sources, so at a time we can consider only one energy source, and for all other voltage sources, that they could be represented by the short circuit wire, and all other current sources can be represented as open circuit. So we're going to apply superposition theorem here. Let's first consider this 6-volt battery source. So if I'm going to consider this energy source, so my this 5 ampere current source will be open circuited, and this 10-volt battery source will be short circuited. So in this case my circuit will be like this. Six volt, this resistor 5 ampere, and I need to find out the voltage across terminal A and B. And you can see that this resistor 5 ohm resistor is connected parallel with the 6-volt battery. So my voltage may be my VAB, or I can name it at first, because it's the first source, as 6 volt. Right? Now in the second case, if I may consider the 5 ampere current source, so I will apply I will represent all other voltage sources with a short circuit wire. So my current source is 5 ampere value. My effective circuit will be somewhat like this. Now here you can see that this 5 ohm resistor network has been short circuited by this parallel wire. So my resistor will be shorted. It is shorted because this resistor and 5 ampere 5 ohm resistor and this short circuit wire are in parallel. So effectively this network will be look like something like this. 5 ampere with the parallel wire. So my VAB will be, in this case my VAB from this 5 ampere current source is 0. So now let's consider the remaining energy source, that is my 10-volt energy source. So now if I may draw the effective circuit in this case, so my 6-volt battery source will be short circuited and my 5 ampere current source will be open circuited. So in this case my network will be something like this: 5 ohm, 10 volt, A and B. So we always know that my current always flows in a closed path. So in this case we have only one single path. This 5 ohm resistor is again shorted by this battery. So my effective network will be something like this. 5 ohm resistor is shorted by this wire. So my effective network is something like this. AB is a 10-volt battery. So voltage across V and A to B is 10 volt. So it is third. So from the first case we have received the voltage of 6 volt, VAB 6 volt. From the second case we have received a 0 volt, and from the third case we have received a 10 volt voltage, 10 volt. So now if I get the overall VAB, which will be the sum of the VAB first plus VAB second plus VAB third, so it will be 6 plus 0 plus 10 equal to 16 volt. My voltage across terminal A to B is 16 volt. So my correct option is option C. My option C is my correct option in this case. Thank you.